Hi there guys, and welcome to the third tutorial in the Genome series. I am glad you guys liked it, at least according to the feedback I got. It's awesome, so I'm going to continue definitely because I like it myself, at least this form of tutorials instead of writing things down, because when I write things down I'm always like, I would like to say this and that, but I can't because it would mess the hello world or whatever simple tutorials, so I can just chat away in this series. So, as I said, in this tutorial we are going to get customized with the custom components. But before I'm going to delve into that, some of you people asked me where are the source codes for the previous tutorials, and I'm going to tell you that there are no source codes for the previous tutorials because it was really simple and I don't see a reason for such a source code for that. If you are still interested for any kind of examples, you can find them on the GitHub. It's a GitHub positive Genome2D, and as you can see there are a couple. There will be more in the future, so check it out. If you are interested in something very specific that's not already covered, just let me know and I will do an example on that. I have a few examples on the functions that are currently even in VIP in latest builds, so if anyone is too eager to test it, just let me know, like the spriter for example. Anyway, let's start on the components. In many frameworks or even in native display list, when you are going to create a player, for example, first thing you do is extend some class, sprite, most probably, or movie clip, and then you add a functionality of a player to that sprite on top of it, and just changing like that, and then add it to the display list so it is a sprite and a player at the same time. In component-based frameworks, it doesn't work like that. We will do a component which is a separate module, and it can be added to any node or removed from the node and add the functionality to the node. I saw some people extending the G-node directly in Genome. I would advise against it. It's possible. Anything is possible after all. So, but you can mess things up if you override something that's does some internal stuff that you didn't account for. But if you really need it, if you feel like you really need to override the G-node class, just let me know why, and I will tell you if it's not feasible or if I should do something on my part in the Genome framework to make your life easier. So we are going to create our first component in the com tutorial package. It will be a move component, and we will extend a G component. A G component is an abstract superclass for all the components. You always need to extend it. It only contains abstract method. There is nothing there, and of course it contains some very specific properties like the node, the reference to a node. That's why the constructor always needs a node. This is the node that the component will be added to. Single component can only be on a single node. That's something I didn't mention earlier. So you can't have one instance of a component and attach it to multiple nodes because it will not work. So this reference is always to that single node the component is attached to. Okay, let's look at the methods. There are two main methods we are probably going to override, and the first one is update and the second one is render. This one is called in the update cycle and this one in the render cycle. It's obvious. Most frameworks have only one cycle that updates and renders the stuff, but in my case, I decided to go with the 2. Is a little bit slower, but it has its purpose because there's, for example, cameras. If we have like 5 cameras, we will only call 1 update, but 5 render cycles. So it wouldn't be wise to call 5 updates and 5 renders on each camera, because it would mean that the object in the second camera is 1 update cycle or physics step or anything ahead. It would be possible even with 1 cycle, but it would need less modularity and kind of a mess of a camera code. Anyway, we are going to play with the update in this particular tutorial. So as you can see, I added a tween light here. It's a GreenSock library, great library for tweening stuff. Genome doesn't contain any tweening internally because there are tons of tween libraries, so I didn't see a reason to. I prefer tween light. You can use anything. And what we are going to do with this player or this move component is to check where user clicked and move the node that's attached to the component, or this component is attached to that specific position. So let's check where or if user clicked. In this case, we are going to listen on the stage, obviously, and since this is not a native display list, we can't just refer stage because this is not sprite, or that doesn't extend sprite, but there is a way to always access stage, because we have the reference to the node, which always keeps a reference to the genome. This is the genome core. It's the same as typing this. This is the same thing. So, and genome always keeps the reference to the stage. So we can easily add a listener, mouse click listener to the stage itself. This way we can mix native events or touch events, for example, with Genome2D code very easily. I do that almost in any project because it's not always feasible to just use the signals. For example, for touching stage, I don't see a reason to use it on the genome structures. Okay, now once we clicked this stage, we are going to tween the node to that particular location. We can do things like setting it here and then checking if it was changed and in update start the tween. I think I will go without even overriding this method. I just do it here. So we have the reference to the node. We are going to tween the transform in, let's say, 1 second, and we are going to set the X to event stage X and the Y to the event stage Y. Simple as that. So let's go back to our main code. As you can see, we create our crate here. Let's run it just to be sure. Okay, there is our crate at random position. Now if we are going to click, it's not going to do anything because the crate is just a sprite on a node. We didn't attach the component to the node, our custom component. So we are going to attach it now, the sprite node. With the movie clip in previous tutorial, we created the node first and then attached the movie clip. That's why we had the node reference directly, but since we don't have it here, some people use that approach just for readability, but I don't need it here. So sprite, the node, and add component. and we are going to add the move component, nothing else. As you can see, now we will have two components on that node, the sprite and our custom move. Let's run it. As you can see, it works. It goes very quick. It's very choppy because the video recording Flash is always choppy when I record it. I don't know why. We can also try to set the frame rate to 60 because I think default is 25. Let's try it out. It's better, but still the video overhead is quite large. So now we are going to add our second component. I want you to know that I could easily do it here in this component, but I want to just show it that how multiple components can work, because now even on this particular node we have two components working, but we will have three. Let's create a look component. And now we are going to override, yeah, finally, override the update method. What we are going to do is let the crate look where the current mouse is. So we are going to calculate the difference between the mouse position and the node position. So as we already know, we can easily get the mouse position from the stage reference, and we need the node position. Since we are our nodes are on the stage or on the root, the X will work. But if we had some kind of hierarchy going on, the X is referring to the local coordinate system, not the world coordinate system. To get the world coordinate system, there are multiple solutions. For example, the world position, we can get it like this, and node transform local to world, a new vector 0 0 will get us a world position. In this case, since we are the local and the world is the same, it would return the 0 0 as well. Another solution is to access, and this is the fastest solution, to access the world position property directly, but this one is not public because it's not intended to be public, but you can access it using the genome namespace. And now you have access to the n world X. As you can see, there are multiple such properties. It's not advised to access them unless you know what you are doing, because you can mess up the internals. But if you just want to get them out, you can do that safely. Maybe later I will add the getters, just the getters for these kind of transforms, but even in that case it will be always faster to just use the namespace and access it like this, because there is no overhead for accessing like this, whereas the getter is a function call. So we are going back to the local. We'll do the same thing for the y coordinate. And now we are going to set the rotation for that node to, as most of you probably know, the magical function of atan2, which will just get us the radians for the coordinates in a circle. So now we have our look component. let's just change this to the look component. As you can see, our crate is looking at us. We can't move it because we removed the move component. So now let's add both of them. Oh, Moog, that's funny. And it works. This is very handy if you have things that you just want to attach, test, and then remove, or attach just for a while and then remove just to avoid an overhead. Or for example in debugging, where you just this runs in debugging, so there will be this debugging, so there will be this debugging component that's not in the normal runtime. It's how Unity does things as well, or other component-based runtimes. Whereas in inheritance frameworks like the native display list or stuff, if you had this on your player, you can't remove it. You need to physically remove it, the moving part. Or you can't add, now you have, for example, an enemy or thing I want, that now I want to control the enemy. You can't just plug in the moving functionality. You need to copy paste it from the player and add it to the enemy and then remove it later, which is a lot of work. So it's quite nice, and it also enhances the readability of the code. As I said, both of these things could be done in a single component, because I mean, just copy paste this to here and it will work. But I wanted to show the modularity of the component approach. I see that we still have a little bit of time, so let's have fun. Remove the move component and create a few more crates, let's say 50. As you can see, they are all following us. Now what we are going to do is add a mouse listener to the crates and add the move component to the crate we clicked and remove it from the crate that already had it, if there was one that had it. So we'll always move just one of the crates. Let's add the property of the selected crate. So we want to remove the move component if there is an active selected crate. We will simply remove the component. It's easy, just remove the move component. As you can see, there is this lookup class, not the component class, as in the add component, because it is a little bit difficult to explain, because this is the class that's for the lookup, internal lookup in the component dictionary, and this is the class that's instanced. That's the actual component. Because in many cases we want to have, especially if we are going to inherit and extend the specific component multiple times. For example, we had 10 10 players or player nodes, and 5 of them would have a component, a sprite component, and 5 of them would have movie clip component because they will be animated and the other 5 will not. And now we wanted to have a single pipeline to remove remove the component, but we would need to check if there is a sprite on this player or there is a movie clip component on this player. What we can do is, well, when we are adding the component, we could do we are adding the sprite, but the lookup would be the texture quad component, which is superclass for the sprite. So, and other players would have like G movie clip, but also use the texture quad for the lookup. So in later code where we are going to remove this, we can simply remove, or we can do anything with it pretty much to get or remove the component. We can just refer to it through using the lookup class. As I said, this is especially handy. We are using inheritance in our components because this way we can just get component using the texture quad, which would get us the sprite or the movie clip, doesn't matter, because both of them are texture quad and work on them, like visibility or stuff like that. This is way too advanced anyway at this point in time, but if you are just interested in it, some people requested it and I use it multiple times. So let's back to this component, move component that we are removed. If there is a selected crate, we don't even need these. And now we are going to assign the selected crate to the current clicked selected crate. And now we can add component, the move component, to the selected crate. Let's try it out. Select this one. Oh, it doesn't work. I wonder why. As usual, I forgot to enable the mouse enabled. That's the optimization, that the mouse enabled is by default false. I always forget it because in native display list, well, it was always true. So now it should work. Nothing moves because nothing is selected. Let's select this one and it will move. Now select this one. Oh, this is a little bit of a problem with working on events, on stage events inside components. I didn't intend to have this in this tutorial, but if you are going to run into such problem, this means that this code was executed after we removed the component. So this will not work because this node doesn't exist, because this component was removed from that node. This is why we need to clear things up, because this event shouldn't be there anymore. But since we didn't clean it up, and Genome cannot clean this up for us because it doesn't know that we added some kind of listener to anything. This doesn't need to be staged. It can be a listener to, for example, asynchronous events in our asset manager or anything. So we always need to clean the house. So that's why there is an abstract dispose method, and that will be called once the component is removed from the node, or the node is disposed, or in any case. So let's remove it. Now it will no longer listen, because in this case it would mean that we are removing this component from from this crate, but it's still executing its side. It cannot be garbage collected because there is this hook. And keep in mind that this is not the same component. This is not the same instance of the move component. This is the remove destroys the component, add component creates a new component. There is no way to reuse the component instances, and it would be pointless because there is a lot of thing going on in the background. So let's we clean the house in the component, and now we can try to run it again. Okay, it moves. Now select this one. As you can see, it works. Now, since we have a little bit of time, I'm going to delve into another topic. This can get kind of messy. We are going to work on this in some kind of our enemy manager or stuff like this. What we can do is create a component that will create the other components for us. So let's say we want to let's call it the crate component. So it's a node. Everyone knows this code already, and we are going to move most of this code here. Sprite, this will be on this. Var sprite is, I'm using a local reference. You are probably going to store a class reference to the sprite, to the loop component, to the move component later, and stuff like that. And now this is a gsprite node, which is this node, the crate node, crate component node. Add component gsprite. We will need to have this outside because we need the global reference to the selected node. So let's move this here, and here we are going to create the crate component using the factory with crate component. Now we need the mouse click. We don't need to set the mouse enabled because we are doing it inside the crate component. We can, but it will be redundant. Now we are going to add it to the root. And run it. As you can see, all of the crates are there, but they are the 00 because we forgot to set the position here. And they are there, and they work. So as you can see, that you are not limited inside the component. Components can work as complex managers of the whole scene. You can have a single component, a scene component on a root. I would advise against the root. I would create a, let's say, game encapsulator and add it to the root, and then add the component to the root, to the encapsulator. but you can do pretty much anything there. You can create components. You can even create additional nodes and add them to the like child Gnode factory, create node, and now add it as a child to this node, which is this component is attached to. So you can pretty much create the whole scene, and it's way more manageable than having some kind of linear code here, like okay, let's like create and now linearly add like hundreds of components or multiple components, because most people were when they read into the tutorials or examples thought that you need to do it like that, but I don't know why they thought it, but it's simple. You can do pretty much anything on the inside the component at all the other components. We could also for readability do like function the add move and add the move component here, and then on or remove move, and then here only call the add move or remove move instead of the native methods, just for the readability of the code. Of course, you wouldn't be able to call it on this because this is the node, and we will need the reference to the create component, since that's the manager of this player or whatever it is. So I hope you learned something here today. I'm not sure what I'm going to talk about in the next tutorial. If anyone is interested in something specific, let me know. I can talk about emitters, about cameras. That's probably the best thing to do in the next, or masking or whatever. And later, if I run out of topics or I'm just bored, I will probably start a tutorial on how to create a simple game from the scratch. So you'll see all this stuff, but used in a streamlined fashion, and how to create a simple shooter probably. Okay, thanks for listening and let me know. See ya.